this video, we're going to be laying out the first cell and section. So this is the section that we're going to be building. First is these nearby places. So we're going to lay out these individual cells and get this section working. The first thing we need to do is actually use our header view in the home view. So this dividing line in the spec that we're building kind of shows we have a collection view down here and a header view up here. So we need to split our home view into those two parts because right now it's just all one piece. So we're going to go to the home view, and it is going to have a header view, which equals a header view that we defined in the last video. And we're going to have a collection view, which equals a UICollectionView. We don't care about it at all right now. We don't actually care about the collection view at all right now. We're just going to use an empty one to hold some space until we build out the real collection view. So what we're going to do right now is set the collection view's background color equal to system pink, again, so we can see where it's at on screen before we get content in there. And then we need to add some constraints. So in the constraint function, again, this pattern is defined in my laying out UI code in Swift video. These two methods come from this programmatic view. I'm not going to go into it into detail here, but what we need to do is add the subviews, header view and collection view. The header view is top anchor, needs to equal the top anchor of the home view. The header view's horizontal anchors need to equal the view's horizontal anchors. And the header view's bottom anchor needs to equal the collection view's top anchor. Then the collection view horizontal anchors need to equal the view's horizontal anchors, and the collection view's bottom anchor needs to equal the view's bottom anchor. That should be all the constraints we need. Now if we run the app, we're going to see that it's all teal. If you remember from the last video, our collection view is pink, but our header view is teal. So that means what we're seeing right now is that the header view is taking up all the space. And the reason that is because that is the first layout that satisfies all the constraints. We don't have anything constraining the height of the header view currently. So it's just taking up all the available space. So what we're going to do in the header view's constraint method is set the height anchor equal to 100. Now if we run it, we'll see that's roughly what it would look like when the header is fully collapsed. So that'll give us a good working canvas to build out the collection view from until we get to the header. So I'm going to use collection view to build these layouts, and I'm going to use compositional layout to do it. But I'm going to try to break things up in a way that makes these pieces as reusable as possible and as kind of abstract as possible, so that I can just grab this code and drop it into new projects if I need to. So the first thing I want to do is add a folder, a group. This is where we're going to put our collection view elements. And that's going to have a new file in it. We're going to build a SmallSquareCell. This is going to be one of our building blocks. This cell here is what we're going to define. So we need to have a square image, hence small square. And it's a UICollectionViewCell, so cell. So first thing we need to do is import anchorage in UIKit. Now what I'm going to do is define this as a view so that I can use my programmatic view subclass like I normally do, and then just provide a wrapper around that to be the collection view cell conformance. So the first thing, we just need to define the view. So I'm going to have a final class called SmallSquareView, which is a programmatic view. It needs to have a few elements. It's going to have an image view. It's going to have a stack view. It's going to have a title label. And it's going to have a subtitle label. Then in configure, we need to set up some pieces. We're going to have the image views, background color equal secondary fill, secondary system fill. That will just let us know if we don't have an image. That'll just be the default color to show that there should be an image there. And we're going to set the layers corner radius equal to 8, and image views layer mask to bounds equal to true. Then we need to set our stacks axis to vertical and the spacing equal to 8. I believe both of those are the defaults, but I like to be explicit about it. Then in our constrain method, we're going to add subviews, the image view and the stack to the overall view, and then to the stack we're going to add arranged subviews, the title label and the subtitle label. Then our image views vertical anchors are going to equal the vertical anchors of the view. The leading anchor is going to equal the leading anchor, and the image views width anchor is going to equal the height anchor. That'll give us the 1-to-1 ratio. It'll take the full height of the cell and then start at the leading edge. Then for the stack, we're going to set its leading anchor equal to the image views trailing anchor plus 10, and the stacks trailing anchor equal to the trailing anchor of the view, and the stacks center Y anchor equal to the center Y anchor of the view. So that will lead to this layout where the cell starts here and it's this tall, and here's the bottom. So the image is taking the full height and it's all the way to the leading edge of the cell. There's 10 points of space between the image and the stack view, and then the stack view will take as much height as it needs and center itself in the middle of the cell. And that gets us pretty close to what we need. The only thing is the fonts that we're missing. So now we're going to add the custom fonts. The way I like to do this is to define the fonts, the custom font style, as a private static variable, and then provide a function with an enum that at the call site lets you select one of those static fonts and shows that we're using our custom font, not just something from the system. So what that looks like in practice is this. We're going to add a private static variable called headline, which is a UI font. We're going to use UI font metrics so that our font is scalable. We're going to use the system text style headline. We're going to try to keep our custom fonts in line with the system font styles so that they scale correctly. We're going to add a scaled font. And I'm going to move this down to the next line just because it gets a little long. And the font we're going to use is just the system font. If you had a custom font, you could put that here as well. For headlines, we're going to do 14 and a weight of semi-bold. Now I came to these custom fonts, I'm using in air quotes, by just playing around with it and trying to get it as close to what was in the Airbnb app as possible. But so for the headline, that's what we'll do. And then we're going to add another one called subheadline, which will use the subheadline style and will be of size 12 and lightweight. So here's where we'll define the actual custom fonts. You could point them at custom font files or whatever. And then I'm going to have a second extension where we define a custom style enum. And then a static custom function. Which will just switch on the style. And return the corresponding font style. So I know this seems like a little bit much, but I like that it lets you provide custom fonts in a abstracted out way. It defines all this stuff in one place where it's pretty easy to read what's going on. It lets you control what font styles are publicly accessible. So we have to add them to the style enum and have to add it to our switch statement for them to be publicly available. And I think it makes it pretty clear at the call site what we're doing, that we're using one of our app's custom font styles. So we're going to go back to SmallSquareCell and I'll show you what this looks like in practice. So for the title label font, we're going to set it equal to custom style headline and subtitle So this makes it really clear. It makes autocomplete easy because anytime you're always using .custom and then you just have a small list of styles to choose from. This is very clear. Even if someone is not familiar with this code base, they could look at this file and know exactly what's going on here. They just need to go find this headline style and see what it is if they care specifically what font size it is. Okay, now we need a way to take in content and put it into this view. So how we're going to do that for this app is use this method called configure with content, which is going to take an optional piece of content. And all it's going to do is set the title label's text equal to the contents title and the subtitle label text to the contents subtitle, and the image views image equal to UI image named. Here's where we're going to use our custom initializer, content image. This is optional that we're passing in, so if we didn't have this extension, we would have to unwrap this first, but this reads a lot cleaner in my opinion and does the same thing. Okay, so now we have a view for the cell that should in theory look like this if it's given the right size constraints, but we need to put it in a cell so that we can actually show it in our collection view. So what we're going to do is define a class called SmallSquareCell SmallSquareCell, which is a UICollectionViewCell. And this is going to have a private lazy var called view, which is a small square view. We need to override the initializer from frame. We're just going to call super init from frame, pass in the same frame, and call constrain, which we haven't defined yet, but we can do that right now. And this won't build because we need the required initializer. So let's throw that in there. But you can just use a fatal error if you want. You could also just call the superclass different coder and then call constraint. So the constrain method doesn't need to do much. Try to keep this dumb as possible. It's just a wrapper around the view. What we need to do though is take the content view, which is we get from the UICollectionViewCell, and add a subview, which is our view. And then we need to set the view's edge anchors equal to the content view's edge anchors. So the view is just going to take up the full size of the content view that is given. Then we need a way to pass our content down to the view. So we're going to have this pass through function called configure with content. And all it's going to do is call configure with content on the view. So that's the entirety of our wrapper for now. We've got our view, got our cell. Now we need a section. So we need a way to lay out this section, which is pretty easy using UICollectionView compositional layout. We just need to define a NS collection layout section for this section to use in our UICollectionView compositional layout. The names are really long, but it does make this stuff pretty easy and reusable. So what I'm going to do is in this collection view elements group, add another new file called NS collection layout section plus layouts. That will need UIKit. This will be an extension on NS collection layout section. We're going to define this as a static function called side scrolling to item. The reason I'm calling it that is because we have 2 items tall and it's side scrolling. It could be side paging, I suppose, but side scrolling is what I chose to go with. And that will be this kind of section. The reason I'm calling it that and not nearby section or whatever is that we can reuse this layout anywhere we want. And so we're defining it more semantically of what the layout is so that we can just drop it in wherever. Okay, so this section is made up of a bunch of different parts. So you have the overall section is kind of this space. And then you have groups, which are kind of this space. This is a group of 2 items. And then you have items, which this is 1 item. This is the second item. So you have an item and then a group and then a section. So we first need to define our item size. So we're going to take the item size and set that equal to an NS collection layout size. which is going to have a width dimension, fractional width of 1, and a height dimension estimated 85. What this says is this item is going to take the full width of its super view parent, the size of the group in this case. The height dimension we're going to calculate based off the content, but we're going to estimate it's going to be about 85 pixels tall, which I'm just kind of making up to get close. Now we need an item. We'll do NS collection layout item from that size. We're going to set some content insets on this. So item.content insets. We're going to put 8 on the top and bottom, 0 on the trailing edges. That'll give us this space between the two. Next, we need a group size, which is also going to be an NS collection layout size. It's going to have a width dimension of a fractional width of 0.65 and a height dimension of estimated 180. So this width dimension is just a rough guess based off of how much space this group looks like it's taking. And again, it was kind of based off of what the original layout was. It might be a little more or less, but I'm just kind of guessing. The group should take roughly 0.65% of the full width of the section. And then that height comes from, roughly speaking, these set items are going to be 85. So that's 2 times 85 is 170 plus a little space in the middle. 180 may or may not be it, but that's pretty close probably. Then we need a section. So here's where we're going to make the NS collection layout section. We're going to make it from the group. Oh, we need a group. We have a group size. Now we need a group. So this will be NS collection layout group. It's going to be a vertical layout, which uses the group size. The sub item will be item. The count will be 2. Now we have a group. We can make our section. And we need to add a few properties on the section. So the orthogonal scrolling behavior is going to be group paging. There are a lot of different options. For the scrolling behavior, you have continuous group leading boundary. You can read all the definitions for them. Group paging centered, paging, etc. We're going to use group paging because we want this group to land kind of at the front line and stop on the content. So it won't let you stop in the middle. It'll pick one or the other to page 2. And the last one ends at the content inset on this side. Okay, then we need some intergroup spacing. Set that to 12, and we'll set some insets. We'll do 20 on all sides. Then we just need to return this section because we said we would. So now we have a layout defined. We need to have some sort of conception for the sections. We need a model. We need to be able to model that somehow. So if we go to our content, we need to add a section model, which will be an enum. It's going to have a raw value type of int. It's going to be hashable. It's going to be case iterable. I'll explain why in a minute. For now, we need a case nearby. That's this section. It's nearby places. Then later we'll add stays, experiences, hosting, and info. But for now, we'll just comment all those out because we're only building the first section. Now we also need to uncomment out the stub data. So we need to uncomment out section and stub data and the switch. And these three close brackets. And then we can just uncomment out the nearby case. And I think that will compile. Yep. Cool. So now we have our content for our first section. We have our data model, we have our layout, we have our cell. We just need to build the collection view. So we are going to use a initializer for UICollectionView compositional layout, which takes a closure. And in that closure, we're given a section index and a layout environment. We need to return an NS collection layout section. And since we defined our section as a static function on NS collection layout section, we can just use dot syntax to pick our layout, or pick our layout. So what we're going to do is in home view, I'm going to make an extension. We're going to add a function called makeCollectionView. That's going to return a UICollectionView. So the first thing we're going to do is make a layout. Actually, a compositional layout. It uses this initializer with a section index and a layout environment. So the first thing we're going to do is grab our section. Let section equal section.allCases at the section index. We're going to switch on that section. And in the case that it's nearby, we're going to return the side scrolling 2-item section. So now we have a layout. We just need to return a UI collection view that uses that layout. We don't care about the frame. We're using constraints and the layout. So now we have a way to build a collection view. I know this probably seems like a lot of overhead just to return this one section, but as we add sections in the future, this will give us a convenient place to just define the new layouts for the new sections. Now, up at our collection view definition, we can use this make collection view function to build that collection view. Except it can't be a constant anymore. We need to make it a lazy var so that this gets called after initialization. Okay, now we have a collection view. Now we need a data source to give it. We're going to use UI collection view diffable data source because that seems to be the best practice moving forward. And this takes the whole nested closure and closures in an initializers thing to another level. There's several layers of closures happening here, so it can be kind of complex, but I'll try to suss it out as best as I can. We are also going to use UICollectionViewCell registration for this because, again, that seems to be the best practice, but those are only available on iOS 14 and forward. So if you need to support an older app or an older OS version for your app, that's probably not an option for you yet. But we're using the latest and greatest here, so we can use them. And the registration initializer also takes a closure. So let's just get into it and we'll see how it looks. So we need a function called make data source, which is going to return a UI collection view diffable data source of type section content. Okay. So we need a registration for our cell. So let's define that first. We're going to say let registration equal UI collection view dot cell registration of type SmallSquareCell to content. And that this is an initializer that takes a closure. We're using trailing closure syntax. In this closure, we get a cell, an index path, and a piece of content. And we need to return well, we don't need to return anything. We need to configure our cell with the content that we're given. So this cell will be of whatever type is the first generic parameter, and this content will be the type of whatever this one is. So I've called them cell and content because that's what they are here. And we actually don't care about the index path because we're just given the content. So I'm just going to put underscore there. So all we need to do here is configure the cell because we give ourselves a nice interface on the cell to configure it with content. So that's all we've got to do in the registration. Next, we need to make a data source. Of type section to content. This also has an initializer, which takes a trailing closure, but it also needs a collection view. Collection view cell provider. So collection view, we're going to pass in our collection view, and the cell provider is a closure that takes a collection view, or that's given a collection view, an index path, and a piece of content. And it needs to return a UICollectionViewCell. So what we're going to do here is figure out what section we're dealing with. And this is why we made section case iterable, is because we're going to use the all cases in a bunch of places. And that the compiler will generate this for us just by us declaring that it's case iterable. So we're going to grab the section. We're going to switch on the section. If it's nearby, remember we need to return a UI collection view cell. So we're going to return our collection views. I'm going to name this view so that it doesn't conflict with the collection view of home view, and then namespace is clear. So view collection views have this DQ configured reusable cell function using a registration and an index path and an item. So we have all those things. We're going to use the registration that we defined here. We are given an index path here, and we are given an item here. So we can just pass all those through, and this DQ configured reusable cell will DQ a cell from the collection view, set it up with this content as that's where we'll call configure here. So that's how we get the content passed in, and then it will return it. So that's all we need to do there. And then at the end of this function, we need to return the data source at the end of make data source. Now, while we're here, this is okay, but it will get kind of out of hand because we're going to have 4 different cells, I think. And if you have to define all the registrations like this in the make data source function, it starts to grow and look a little complicated. But so what I'm going to do, because this is a registration of SmallSquareCell, I'm going to define that as a static function on SmallSquareCell itself. So I'm going to grab this registration. I'm going to hit Command X to cut it and go to SmallSquareCell and paste it in here. Actually, we're going to define a static function. And return it here. So this function, it's doing the same thing as we did before, but I like to keep it here because it is close to the content that it's actually configuring. And then it makes it clear at the call site that we are using the SmallSquareCell. So we're going to say let registration equals SmallSquareCell. That registration, and that will work just fine as well. Okay, so now we have a function to make a data source. We actually need to use it. So we're going to add another private lazy variable called data source, which is equal to make data source. Then in configure, we're going to make this a more reasonable color. We're going to set this to system background and set our data source. Now we need to hook it up to something. So the data source has a method called apply snapshot, but for architectural reasons, I don't really want to expose the whole data source. I only want to expose the ability to update it, to apply snapshots to it from outside of here. I also don't want to deal with the data inside of this view. So I need to expose that to somebody higher up the chain. So what we're going to do is make an internal function called apply snapshot, which is going to take an ns diffable data source snapshot of type section to content. And all it's going to do is call that on the data source. So the view owns this data source, but it's not doing anything with the data internally. It doesn't have any data to give it. It's just taking whatever snapshot it's given and passing it on. Then in the home view controller, we're going to add a function called update list. In a real app, you would fetch your data, obviously, from like some sort of network layer or database or something. Here, I'm just mimicking that with this function. But so we're going to make a snapshot, which is an ns diffable data source snapshot of type section to content. We are going to apply or append sections, section to all cases. We want all of our sections in there. Then for section to all cases for each, we are going to say snapshot append items. The sections stub data to the section. And then we need to call on our content view, apply snapshot. Then we can pull view.load back up and call update list once the view is loaded. There we go. Now we should be able to see our section, all of our hard work is showing up on screen. It's scrollable, it should page correctly, and it looks great. We can see it in comparison to the final product. We can see it kind of in comparison to the original screenshot. The fonts and weights aren't perfect, but it's pretty close. And that is all we need for this section. As a reminder, in this video, we filled out the view and the collection view cell. We laid out the section. We made a collection view and the data source to power that collection view. And in the next video, we will lay out the rest of the collection view. See you then.